We're going to do a calculation for a wheel and axle's mechanical advantage, and so again we'll first start with our diagram. So I'm going to draw an axle. On that axle we'll put the fulcrum. Then I will draw the wheel. And so if we have a point, and the fulcrum should go there to the middle, the axle. Draw a straight line to the fulcrum. Then we can start putting some forces on this. So I'm going to put a force right here that's pushing up. We're going to call that a 70-pound force. Put an opposing force right here, and it's going to be a 200-pound force. And I'm going to give the larger wheel a diameter of 20 inches. I'm going to give the smaller axle a diameter of 6 inches. The diameter sign in front of the 20. Okay, and so remember there's two ways that this can work. The wheel can be driving the axle, and so I'm turning the wheel, and when I turn the wheel, the axle turns. Or the axle can be driving the wheel, and so I turn the axle and the wheel turns. And so for our first calculation, we're going to do it where the axle is driving the wheel. So remember that IMA is equal to the distance of the effort over the distance to the resistance. And so if the axle is driving the wheel, the effort is going to be put in right here at the axle. And so the effort, DE, the distance to the effort, is going to be that 6 inches. The resistance is being, if the axle is driving the wheel, this is turning and this big wheel is resisting it, is going to be at the wheel. And so in this case, the distance to the resistance is going to be 20 inches. So you divide that out, and you get a mechanical advantage of 0.3. And another way that you could describe that is a 3 to 10 mechanical advantage. So you're putting in more effort than you're getting out of the system in this case. We'll do another one where the wheel is driving the axle. So let's do the other calculation, where the wheel drives the axle. Again, IMA, we'll do IMA, is equal to the distance of the effort over the distance to the resistance. In this case, our effort, if this wheel is driving the axle, like we're turning a knob on a radio or something like that, the effort is put in at the wheel. And so I'll put our 20 inches on top. That's the effort now. The resistance is on the bottom. That's 6 inches. You get a mechanical advantage of about 3.33. So that makes sense that I am gaining something by I'm gaining less effort force by using this system where the wheel drives the axle. If we solve for AMA now, where the wheel's driving the axle, AMA is equal to the force of the resistance divided by the force of the effort. So in this case, the force of the resistance is coming right here. Here's our resistance force. It's 200 pounds. The force of the effort is 70 pounds because we're putting the 70 pounds in at the wheel. Divide those out, about 2.86 for the actual mechanical advantage. And remember, the actual mechanical advantage is where friction is taken into consideration. Lastly, we can do a percent efficiency for the system. It's equal to the AMA over the IMA. If we want to get in percent form, we can multiply that by 100. So the AMA of the wheel driving the axle was 2.86 divided by the IMA, which was 3.33, and you get a multiplied by 100, and you get an efficiency of about 85.9%. There are some calculations on the wheel and axle.